Well, it's 7 o'clock, so we're going to go ahead and get started. But I would like to just do a quick tech check and make sure that you can hear me loud and clear. Thanks, Gretel. And also, I am sharing a screen that says Exploring Unfamiliar Data Sets with Data Classroom. And are you able to see that screen share? Perfect. Thanks very much. Before we get started tonight, I'd just like to share a bit of backstory. Um, my name is Nigel Standish, and I'm the Director of Operations for DataClassroom. But a long time ago, in a galaxy far, far away, I was a survival instructor for the Air Force. And you can see my office, or a couple of my offices, in the slide right now. After that, I went to UVA to do a PhD in instructional technology and then was an administrator for a public school district for a few years before coming to Data Classroom. Tonight, we are going to talk about exploring unfamiliar data sets. And kind of the things that we're going to be looking at are some data classroom tools that can help us explore data sets. We'll be going over Nigel's playbook for exploration, which is heavily plagiarized in many ways. So I did not come up with all of these or any of these. I just put them in this order. And then finally, we're going to walk through an example. And the way this outline is written, we have to put it in a certain order, but we're kind of going to be jumping back and forth between all three of these tonight. Now, I am doing this webinar alone. And so if you have questions, I think we have enough people that it probably would be best if we type them out in the chat box. But if for some reason you can't type, feel free to just unmute and shout out. And then at the end of the webinar, I'll stay on for as long as anyone needs to answer whatever questions I can. All right, let's get started. So when you find a data set online or in an article that you would like to explore, maybe it's off of Citizen Science or off of Fred's website if you're into economics. There's a few questions that I like to ask about the data set. And just to understand the context of it, who collected the data? Why was it collected? How was it collected? And look at any documentation that comes along with it. This just lets you know kind of the perspective of the scientist or data collectors and how they were going about their collection. And it might give you an insight into any biases or any omissions that might come up later on as you explore. The data set that we're going to be exploring tonight is called, it's a car data set. And this is what it looks like. Let me increase this to maybe that's better. It looks like this. It's quite a large data set. It was collected online by my colleague, Aaron Reedy, and he collected it because he thought it would be a good data set to go over tonight. How it was collected was just by doing a search for car data sets and their prices. And not that one. There we go. It didn't come with any documentation tonight. And we're not going to be exploring super interesting or important questions with that data set. So there's no documentation that we need to go over. So once you've gotten that out of the way, we're going to look at the variables and the types of variables in the data set, how many observations, what's the unit of observation, and what format is it in. So let's take a look at this car data set. And let's answer some questions here. So how many variables and types? Well, we can see that across the top row, there's all these different types of cars. And as we go along, we'll see, okay, lots of different types of BMWs, some Dodges, some Hondas, some Mazdas. Then down this column, there's the weight, the engine size, the horsepower, the peak RPM, the highways, miles per gallon, and the price. And so, as you know, or probably know, most data falls into one of two types, either categorical or numeric. And I'll show you in DataClassroom how you can determine what type of data you have. And if you have something other than numeric and categoric, DataClassroom can help you decide which one to put. But if we look at all of these variables, for example, the weight, the engine size, the horsepower, the RPM, the miles per gallon, and the price, those are all numeric variable types. We haven't broken these out into variables yet, but if we look at the different car types, those are actually not going to be numeric or categorical. They're going to be identifiers for us. Once we have looked at the variables and the types, the observations here are numerous. They go all the way up to column HC. We're going to ask ourselves, what's the unit of observation? And this is like, what was each variable measuring? So what was, what was weight measuring? What was engine size measuring? And as you can probably guess, the unit of observation is the car. It's each of the cars are the unit of observation in this data set. And then finally, formatting. And formatting is where beginning data learners and data set explorers have the most trouble, because oftentimes when we collect data ourselves or when we get data off the internet, it's going to look very similar to what our data set here looks like. It's going to be really wide, and it's not going to be in what's called tidy format. But we can transform this data into tidy format more easily than you think. And if you want a quick definition of what tidy data is, it's just that every variable needs its own column, and every observation needs to be on a row, a single row. And so if you see here, our observations of our unit of observation are not on the same row. They're actually in the same column. And so instead of having this go up and down, we need this to go left and right. And so when we're in Sheets, we can grab these rows and copy them. I'm using Control-C to copy. And then I'm going to come down here and I'm going to right-click. And I'm going to paste special. And when I paste special, I'm going to choose transposed. And now you can see we've got, I'm going to change this variable to name to name the car. You can see now we have, let me delete these. And let me make this bold so it's easier to see. Center. All right. So now we have each column is its own variable. You see how our weight now is all in this one column. And our engine size is all in this column. And our RPM is all in this column. And the reason that we transform messy data into tidy format is because this is the format that machines visualize and analyze data best. And it's not just DataClassroom. SPSS, R, Python, SAS, all of these programs rely on the scientist to format their data into tidy format so it can best be understood by the machine. Now I'm going to pause just for a second since we talked about tidy data and see if there are any questions. I want you to know that at DataClassroom, we love helping format data into tidy format. That is that is not it's not hyperbole or sarcasm. And so it's often the first hurdle that teachers and students come into. So if you have a question about formatting in tidy format, just send us the data set and we'll send it right back to you telling you how we put it into tidy format. Lisa, I think it's going to be the same way. I think there's a special paste in Excel, and you can just choose to paste special transpose. It's been a little while since I've used Excel, so that paste special could live elsewhere instead of the right click. Questions? Yes, Gretel, you've had some fun data sets. I enjoy them very much. All right. Okay, well, let's move on. So we have, let's see what we've got here. All right, so we've looked at the variables and the types, kind of just looking at raw data here. How many observations? What's the unit of observation? What format is it in? And next, we need to start exploring the data. And we're going to do that by bringing the data into DataClassroom. So there are a couple ways to do it. We could download this as a CSV or Excel. Since Excel was brought up, let's download this as an Excel. Or we could copy and paste it. I'll click Control A to select all and Control C to copy. And now we're going to go over to DataClassroom. Now in DataClassroom, this is the dashboard that everybody will see when you log in. And on the left-hand side, there's going to be 3 or 4, depending whether you're a student or a teacher, green buttons. And the second one down is going to be Import Data. We're going to click on Import Data, and we have a few options here. The first option is to fetch data from a spreadsheet on Google Drive. When you do this, it actually creates a web link between your sheet and DataClassroom so that you can update or add data to your sheet. And then when you reload or refresh on DataClassroom, that new data or changed data will be reflected in DataClassroom. The second option is to upload a spreadsheet from your computer. This can be a CSV or an Excel. The third is to just paste data in from a spreadsheet. I haven't found a data set large enough or worked with a data set large enough that copy and paste doesn't work. Just make sure to have your first row as headings if that's how your data is organized. Let's try the upload from Excel. Let's choose a file. Here's our Excel. We'll open it up. We are going to be good data scientists, and we're going to enter a description, car info data. We're going to save. And the reason that it's failed is because somewhere in my data, there is a font that has not been correctly taken from Sheets to Excel. So what we'll do is, instead of an Excel, we will do a CSV and then try again. Close, upload, choose file, CSV, car info data, save. All right. Processing is done. And we can start to see, okay, here's our raw data table. Here are our variables across the top in columns. And here are all our observations down here in rows. Now you'll notice that in the top right of DataClassroom, there's a little flow chart to help you get through your import all the way to statistical tests. And under preparation, we have data import, which we've received a check mark for. But under that, there's prepare, in which we have a caution sign saying that there's some things we need to fix. So if I click on that, it'll tell me, hey, good job. Your data set description has been filled out. However, there is a column or columns that have not had their type set. Now, if I don't know what that means, I can click Learn More, and DataClassroom is going to tell me, here are the 5 main data types. Here are what each one represents. And then there's some tricky cases that you can learn about. If this doesn't satisfy the learning itch, then you can go to our user guide and watch even more videos and read even more text about data types. I'm going to X out of this. I could ignore this if I know I just don't need to worry about it, but I'm going to fix it. So we have our car name. This is our identifier. It's going to give me a little warning that, hey, sometimes identifiers are chosen as types when they're not really identifiers, but in this case, we know they are. Car body, that's a categorical. Drive wheel, categorical. Fuel type, categorical. Cylinder number, categorical. Curb weight, numeric. Engine size, numeric. Horsepower, numeric. RPM, numeric. Miles per gallon, numeric. And price, numeric. And did I miss one? Let's see. For some categorical values are rather long. For example, column 1 has at least one long value. Now, this becomes, I'm going to go on a little, I'm back watching chat now. Yes, so we do have some videos on tidying data found in the user guide. This error is particularly useful when students are collecting data, because a lot of times I've found students like to collect survey data. And so they'll put their answers or their questions in here, and they'll be quite long. And so this is an opportunity to, just say, hey, maybe you don't want this variable or observation being so long. Maybe you want to code it to something a little shorter. Right, but we're going to ignore this for now. and we are going to continue. So now we've got 2 check marks, and we're ready to move on to graphing. So when we start exploring the data visually, we're going to want to start one variable at a time. We want to visualize things like distribution, outliers, and observation differences. In DataClassroom, this becomes very simple. So if we come here, I'm going to just start clicking on some variables across the top. So I look at car body, and I get a visualization of what the distribution of car bodies in this data set is. Not only 6 convertibles and 8 hardtops, but there are 98 sedans in this data set. I'm going to look at drive wheels here. Rear wheel drive, there's 80. Front wheel drive, there's 121, and there's only 9 four-wheel drive vehicles. Let's look at fuel type. All right, most are gas, and there's only 22 diesel. I won't go through all of these, but you can see as I click show on the variable, they start appearing in the variable control panel. And it's as easy as me clicking on the axis that I want my variable to be on for me to show the data. Now, as I get down into these numeric data, maybe I don't want to see them just as rectangular based graphs. I'd like to see them as a dot-based graph. And so I can just change the graph type by clicking here. And that is a different way to view the numeric variables as we go down. And often really helpful for teachers and students to see the raw data as dots and points here. Now, this weight distribution here is quite clumped, and so we might want to just change how that looks a little bit. So let's go up to appearance, and let's change this to be a little bit lighter. Maybe let's try something like this. And we can just change our appearances here in order to just make it easier to see our data points. We can also, change our point size, make it a little smaller, change the point edge width. Let's do this. Let's do a custom color and change the transparency a little bit. And there we can see, let me make these point size a little more. We can kind of see where they're overlapping, gives us a darker color. All right, no questions. So what we are going one variable at a time. As we do that variable at a time, we can see the distribution. We can see outliers, and we can observe anything that, just maybe doesn't make sense, or see any differences as we change the graph types from rectangular to line-based or dot-based. We didn't get to see any segment-based graphs, but there's a segment-based graph. Let's look at one there. And it's easy to just switch through those as needed. So after we've gone through an unfamiliar data set variable by variable, Now we can start exploring relationships, um, just starting with two variables at a time. Um, Before I dive into that, I just want to check back in with you all and make sure everything's copacetic. We're all good? All right. Back to our data. So I think that probably price is, is one that we are interested in. So let's look at price and highway per gallon. I'm going to undo um, the transparency there. All right, close this out. All right, so we're looking now at price on Y and miles per gallon on the left. We'll just connect, we'll throw up a regression line here to see what that looks like. And we can see this, this negative trend where the more miles per gallon a vehicle gets, the cheaper it gets. And that at first seemed a little counterintuitive to me. I said, well, I thought better miles per gallon um, would be more expensive, more desirable. And Aaron immediately said, well, I bet that less miles per gallon means a bigger car. And well, that's an interesting question. We can do that. Let's go up to engine size and see price and engine size. And you can see that that was exactly right. The bigger the engine, the less miles per gallon, and the more expensive. And just to see if bigger cars cost more, let's do the weight. And there again, we can see a positive trend that the heavier the heavier the vehicle, the more it costs. All right, but don't let that little ADD distraction get you from or stop you from just looking at each of the variables together with price. In this case, price is what we've chosen. So peak RPMs doesn't seem to have much of an effect. Horsepower, large effect. Um, we've done engine size and weight. Let's look at cylinder numbers. Well, now we have cylinder numbers as a categorical. Where's that? Let's make that a numeric. Can we do that? We do two numerics? No, we can't. All right. Well, it's put these into bins, um, and you can see the distribution in each bin without comparing to the others. And you'll notice that I've got these out of whack. You can see 2 is here, 6 is down here. Let me just show you how to change that if that happens to you. I want 2 to be at the top. So I'm going to use these arrows to take 2 at the top. So I've got 2, 4. I'm going to bring 5 up. There's 3, 3, and 6 and 8. Let's apply that. And then that kind of can give us a little bit of an idea of how that works. We don't like those colors. We can change the color scale, try something a little more like this. And we can adjust that individually as well. All right, well, let's not get distracted again. Let's go up to fuel type and price. Majority of gas is in here. We don't have a lot of diesel data points, but we can see that gas seems to have some cars that are more expensive than even the highest diesel in this data set. We can do drive wheel and we can do car body as well. See the distributions there. All right. So we've got, we've looked at two variables at a time. We've looked at differences. We've looked at some correlations, particularly between price and vehicle size, and also the miles per gallon. And we can start asking questions and testing hypotheses, just sort of like we did when we saw the miles per gallon as being more cheap, the more economic it got. We came up with a hypothesis that, hey, it's probably vehicle size. The bigger the vehicle, the less miles per gallon it's going to get, and the more expensive it's going to be. We tested that hypothesis. We created some visuals. And if necessary, we can run a statistical test. So let's take one of our first visualizations. Let's do horsepower here. All right, so price and horsepower. We're going to say, okay, our visualization is really strong. It communicates our hypothesis well, but let's run some stats on it to see what we've got. We can do that by clicking the graph-driven hypothesis test, which is right up here next to the appearance button. When we do that, we can click Show Advanced Options. That should be available to everybody. When we do that, we get a list of statistical tests that we can run. Now, you'll learn this, and it's something that I learned more recently than I care to admit, but your question that you're asking determines your graph type. It narrows your graph types down to about 3 different choices, sometimes even less, depending on your question. And once you have your graph type, that graph type normally leads to a single statistical test that you can run. Now, it's not a hard, fast rule, but in most cases, it's going to be true. So here we have a numeric on X and a numeric on Y. And so when DataClassroom looks at that graph and says, hey, you have a numeric on X and you have a numeric on Y.
Nigel?
Yes.
Are we supposed to be seeing the data classroom? Oh, thank you.
I'm putting that slideshow away and I'm just looking every one of you in the eye and just saying, I am so sorry. And thank you for speaking up. That was there a long time, wasn't it? I am so sorry. We have a numeric on X and a numeric on Y. When we run our graph-driven hypothesis test, we click this button here. DataClassroom sees that we have a numeric on X and a numeric on Y, and it says this is a linear regression test. We click Calculate, and we get a pop-up that tells, answers the question of why are we using a linear regression test? When do we use it, and how does it work? And then we can click Calculate, and we get our statistical output. We get our p-value. And if it's our first time working with p-values, we don't completely understand, we can click Explain. And we can use this slider to explore what different p-values really mean. And we can get an idea that p-value is a sliding scale of how confident we are that something is not random chance. In this case, we have a p-value of less than 0.01, and that means we are extremely confident that there's a significant relationship between these two variables that we have. Anytime you see a camera icon, you can click that to copy the table or the graph and paste it to whatever program you're using to do your journaling, or your article, or your presentation.
Nigel, sorry it's loud here. If you look at a different graph, like say you chose a different type of graph, would you then get a different option of statistical test?
Yeah, so let's do that. Great question. And I wasn't able to identify you by your unmutedness quickly, so I can't call you by name, but thank you for a great question.
It's Lisa.
Oh, hey, Lisa. Thanks for that. All right, let's do, oh, you put a suggestion in there, cylinder number. Let's do that. Let's throw a cylinder number here. Okay, so here we have a categorical on X and a numeric on Y. When we click the graph-driven hypothesis test, DataClassroom says, hey, because your graph has more than two values, categorical values on X and a numeric on Y, that's going to be ANOVA data. We can click calculate. We get another pop-up telling us about the ANOVA test. And then we can click calculate. We can run post hoc tests on that ANOVA to get all of the relationships between all of the variables, if we like. And let's throw a third variable just to show. Let's do fuel type, and we'll click, and now we have a two-way ANOVA because we have a categorical on X, a categorical on Z, and a numeric on Y. And we can run that calculation as well. Hopefully that answered the question. There is no AI in this. It's really just a logic chart, because the question narrows the graph type down so much, and the graph type and the variables on it narrow the statistical test down so much. And so it's really just a logic flow chart that's working behind the scenes there to help you out.
Nigel, I saw when you clicked on the graph-driven statistical test, it said try with R, try with Python.
Yep.
What happens if you click that?
Yeah. So those features, let me go and do it again, are part of the university version because lots of, students are working towards Ion Python, but they're also available for K-12. So let's click. Well, let's just recap. Let's take this off for now. All right, we've got a categorical on X and a numeric on Y. This is going to be ANOVA, but we're not going to click calculate here. We're going to try it in R. And it's telling me that I am not college licensed. Well, let me save this really quick. And let me go to my profile. And if you're a teacher, you can do this. Click college. Come back.
So I assume the students have to put college in their profile too, then.
The students, you'd have to just send me an email if you want your students to have access to that. Students don't have the ability to change their profile from K-12 because they get their license from their teacher. So let's run this in R, and you'll see that it generates the R code for that graph, and it annotates every section of the R code. I know it's probably a bit hard to see on your screen. Let me see if I can blow this up a little bit. And so what it's doing is saying, hey, here's how you make that graph in R, but here's what each section of the code is doing. So if you want to change any point of your code, like say you want to change the stroke size or the color, DataClassroom gives you a little bit of annotated to help you know where to change that. You can also run the hypothesis test as well in R. And then it will give you the output there. So, and then you can download that as a CSV. Yeah, for DataClassroom, both Aaron and I are both former high school teachers, and so it was made with K-12 students in mind. But both of us also went to grad school and worked with large data sets and professional applications. And we didn't want to disadvantage K-12 students using DataClassroom if they went on to do data science in the university. And so DataClassroom is made to grow with the student from their very first digital graph all the way up to R or Python. So we have asked some questions, tested some hypotheses, we've created some visuals, we ran some stats, and at 7:41, 4 minutes before scheduled close of webinar, we got to the very last slide.